Hi everyone, we're given the coordinates, we're going to determine if the triangles are congruent. So we want to determine if triangle ABC is congruent to triangle DEF. Now I'm going to do 4 and 6, and I'll leave it to you to do 5 and 7, but I'll tell you if they're congruent or not. So we're going to start with the first one and determine if triangles are congruent. You have to determine if the sides are all congruent. And we're basing this off of side congruence postulate. If all the sides are congruent, then the triangles are congruent. So we're going to use the distance formula given here. And the first thing I'm going to look is the distance from A to B and the distance of line segment DE. And they should be congruent. So the distance of AB line segment equals the square root thing. So we're going to kind of go like that. Do subtract our x's. So that's 4 minus 1 squared plus 1 minus 3 squared. And that gives us the square root of 3 squared plus negative 2 squared. So that's 9 plus 4 equals the square root of 13. So that should equal the distance of D to E. So the distance of D to E is going to be, we're going to go this way. So we have 6 minus 3 squared plus negative 5 minus a negative 3. So that's negative 5 plus 3 squared equals the square root of 3 squared plus negative 2 squared. Again, that's the square root of 13. So those two sides are congruent because they have the same value. Now we have to look at BC with DF. So we're looking at these two. EF. All right. So we're going to do distance of BC. And I'm going to go in the same way. You don't have to go in the same way, but I'm going to look at 5 minus 4 and 3 minus 2. So that's going to be 5 minus 4 squared plus 3 minus 1 squared. So that gives you 1 squared plus 2 squared, and that's 1 plus 4, that's the square root of 5. So that should equal D to E to F. So let's do that one. So we're doing E to F. Now that gives you 7 minus 6 squared plus negative 3 minus a negative 5. And that gives you negative 3 plus 5. So that gives you, again, 1 squared plus negative 2 squared, which equals square root of 5. 1 plus 4. So those two sides are congruent. And finally, I'm going to do A and C with D and F. So we're going to do the distance of AC. So that's going to be square root of 5 minus 1 plus 3 minus 3 squared. And that gives you 4 squared plus 0 squared equals the square root of 16, which equals 4. And now we're doing the distance of D and F, D to F. That gives you D to F, so we're using these two. 7 minus 3 squared plus negative 3 minus a negative 3. So that's negative 3 plus 3 squared. That gives you 4 squared plus 0 squared equals the square root of 16, which equals 4. So these sides are all congruent. That means the triangle's congruent. Now you're going to do number 5, so you can check that out. This is true. The triangles are congruent. And I'm going to do number 6 now. And we have our distance formula, and we're using our side congruence postulate to determine if these two triangles are congruent. So I'm going to do the same thing. AB, the distance of AB, and that should equal the distance of DE. So let's check that out. So we have 6 minus a negative 3. So that's going to be 6 plus 3 plus 1 minus 2 square. That gives you square root of 9 squared plus negative 1 squared. That's 81 plus 1, so that's square root of 82. So let's try DE. So we're doing these two. So negative 2 minus 6 squared plus 4 minus 5 squared. Now that gives you negative 8 squared plus negative 1 squared. That gives you 64 plus 1, so that's square root of 65. Since these two don't match, that means the sides don't match. That means the triangles are not congruent. So not congruent. And we can stop. You don't have to do the other ones. The sides must match. Now I'm going to let you do 7, but I can tell you that 7 is also not congruent. So they're both 6 and 7 are not congruent. But you need to check it out and practice. Thank you. Have a nice day. Bye-bye.